Welcome everyone to the final molecule on the multiple bonds practice. This is sulfur trioxide. So for the formula, I know I have a sulfur, and then tri means 3, and then oxide, that would be oxygen. So 1 sulfur, 3 oxygens. And it does not say it's an ion, so I don't need to add any charges. All right, so for our Lewis dot structure here, again, we're going to need to work on scrap paper. So let me move that to the side. All right, so first I'm going to write down my formula again. And remember, our first step again is to draw the Lewis dot structures for each of those atoms. So sulfur has 6. I know that because it's in group 16. The last digit is 6. So 1, 2, 3, 4. Then I make pairs. All right, and then I have oxygen. 1, 2, 3, 4, 5, 6. And I know I'm just going to say times 3. All right, so then let's count up our total electrons. So 1, 2, 3, 4, 5, 6. And oxygen has 6, and it's times 3. So I have 18. 18 plus 6, I have 24 electrons. You might notice this is a same number that we've had on other structures. So that would give you a clue. Now, if you look on the periodic table, sulfur is below oxygen. So that tells me it's going to be in the center. All right, so let's just draw out our atoms here. All right, I know that's right on the edge. I think you can see. Oops, I just drew an extra. Keeping track. That has 6. And then this has 6. All right, now this presents a bit of a conundrum because we can see that sulfur has 2 pairs here that are already complete and only 2 single electrons. But we can move electrons around. That is okay. All right. So let's just try that. I'm going to keep my lone electron pair there. I'm going to pair up these 2. So right in the rest of them. That was just by itself. All right, I'm going to pair up these 2. And here, I've got 3. So I'm just going to move that electron over there. And so I've moved it there. All right. So let's check again to count total electrons and check the octet rule. So first, 2, 4, 6, 7, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I have the right number of electrons, but let's check the octet rule here. 8, 8, 7, 7. All right, so this actually should look similar to other problems we've done. So let's see, I can tell that this oxygen is going to need to have 8. So I could move that one over there. That's fine. But then that would leave this one with 6. So I can make a double bond by moving those 2 down. Okay, let's try it. All right, so I'm going to space here. All right. So sulfur. So I said I was going to move that one electron up. So that's done. This oxygen, the electrons stay the same. And then I was going to make a double bond down below. So I've got 4 electrons there, oxygen, and then that. All right, so again, let's count our electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Good, 24, check. All right, now let's check our octets. 8. 8. I'll write that down. 8. 8. And 8. We did it. All right. So now, let me just write the final formula right over here. And we're just going to replace the shared electron pairs with lines. I'll draw in my dots in a minute. All right, so we've got the single bond, and then the double bond. Then let me add in all my lone electron pairs. Make those nice and clear. All right, and there's no overall charge, negative or positive, so I don't have to worry about brackets. All right, let's copy it over.